Having a properly calibrated monitor is an essential part of any studio workflow. I'm Ron Nichols, and I'm all about creating studio workflows that are efficient and cost-effective. Monitor calibration is the process of measuring and adjusting the colors on your computer to match a common standard. To properly measure color, you'll need a device called a colorimeter that hangs off your screen during the measurement and adjustment process. Using software specifically designed for this device, the colorimeter measures brightness, then color, then makes adjustments to your monitor. When it's done, it creates a monitor profile that your operating system uses to properly render images to your monitor. When creating a monitor profile, there are three factors used. First is white point. You'll see it listed as a CIE illuminant. Now that's a standard established by the International Commission on Illumination, but it's usually abbreviated CIE for its French name and origin. This is an identifier like D50 and D65 for color temperature standards. In this color model, you can see how as I change the illuminant, the white point moves from yellow spectrum at D50 to more blue at D75. A D65 is the industry standard for photography. D65 renders a color temperature of 6504 degrees Kelvin, or the temperature of daylight at noon. Now we all know that we usually don't want to photograph at noon, but for a monitor setting, we want to use it as it's the cleanest light. You can see that on the color model, it's closest to the center of the white area. I realize this is probably more information than you really wanted to know. The next setting of concern is luminance. This is expressed in candela per square meter. It's brightness. Today's monitors right out of the box are like looking right into a softbox. They are crazy bright. The latest generation of Apple iMac monitors have 500 nits of brightness. That translates to about 500 candelas per square meter. If I look at the specifications for this color-critical NEC display, you can see it has a brightness of 350 candelas per square meter. Luminance is critical. If your monitor is too bright and you adjust your images at that full setting, when they're printed, they will be too dark. In the same respect, if images are judged or reviewed on a monitor set to a lower luminance, they too will display darker than really what you intended. Highlights will be muted and shadows will be blocked up. For the luminance setting, we want to use 120 candelas per square meter. The final setting is gamma. This is the tone response curve that determines how colors are displayed outside of color managed applications, and it translates the proper levels of brightness to something that our eyes can perceive. You want to use 2.2 for this. This is the same for both PCs and Macs. Now, don't worry, you don't have to understand everything behind all of this, and from here on out, I'll keep it simple and practical. The settings that we're going to work with are D65 for our white point, 120 candelas per square meter for luminance, and a gamma of 2.2. Okay, why these settings? Well, this is what is considered industry standard. When an image is viewed on a monitor, the correct representation of that image needs to show on other monitors, or when it's reproduced as a photographic print, or printed on a brochure or in a package. D65, 120, and 2.2 are also the settings used for monitor calibration for PPA's International Photographic Competition and the judging of the World Photographic Cup. But more importantly, these settings will also work in a typical photographic studio workflow environment. Let's take a look at the monitor calibration process. For this process, I'm using an i1 device created by X-Rite. X-Rite's the big dog in the color management industry with a host of equipment and applications for any industry where critical color is essential. They also have various color checker kits that are used for still or video for camera calibration. This simple device will not only calibrate my monitor, but it can also use it to calibrate my digital projector. Now there are other companies out there that offer colorimeters, but X-Rite has always been a solid choice for me since my very first color monitor. Yes, I actually had monitors before they were color monitors. Be sure to have the latest version of your color calibration software loaded. Software is always evolving, so we want to make sure we're using the latest. Next, we'll plug the device into a USB port. Now I suggest going directly into the computer rather than to a hub. We need to make sure that the colorimeter has adequate power to go through this process. We'll launch the software from our applications on a Mac or from your program files on a PC. Now once you have the software running and have gone through the process once, it can be accessed through your system tray, assuming that you've enabled that setting. I'm using the i1 Studio software by X-Rite. The software comes with a device and is downloaded right from the X-Rite website. Under the application info, I can also just check to see if I've got updates. You can see my software is current, so I'm ready to go. Next, I'll select the workflow. Now I'm doing display calibration. You can see that the software has detected two monitors on my system, my iMac and my Samsung. We're going to calibrate the iMac. You have to calibrate each monitor separately. It also detected and set the correct display technology used in the monitor. When I select Photo as an option, notice the settings it automatically assigns. The white point illuminant of D65, a luminance level of 120, and a gamma of 2.2. If these settings are not your default settings for your software, you can just use the custom settings and set them yourself. But notice, that's exactly what we said we were going to use when we started this whole process. The wizard steps you through the process, and it tells me that my device is ready. Now, under Hardware Setup, we have a couple of options. First is ADC, or Automatic Display Control. Not all monitors support this. What it does is it allows software to control your monitor color and brightness. Now, the second option has you manually set up your brightness, contrast, and RGB gains with the software guiding you. If you have a computer that allows changing the monitor brightness from the keyboard, it's really easy to get into trouble after you've done your calibration if you accidentally change your brightness. Now, if you have an external monitor that uses physical buttons or menu systems to make adjustments, you likely won't go in and change those by accident. Now, my iMac has controls in both the system preferences and on the keyboard. Most laptops and all-in-one computers will have a similar situation. Again, those can be problematic, but it's not insurmountable. If your system has a setting to automatically adjust brightness, you need to turn that off. On a Mac, go into your System Preferences, go to Displays, and uncheck Automatically Adjust Brightness. On PCs, go to your System Settings, Display, and uncheck Turn Off Brightness Automatically when lighting changes. Now keep in mind, this wording could change a little bit depending on your operating system version. Back into the calibration software, we're going to choose a manual setup. Rather than clicking Next here, we choose Start Measurement. This is the time when I'll give my monitor a quick cleaning with a soft lens wipe. Next, I'm going to turn my monitor brightness all the way up. Now, you only need to do this if you have the keyboard brightness controls as I mentioned earlier. If it's set to full, I'll know the correct position of the setting when I'm working on it on a daily basis. If your monitor is controlled by buttons or menus, don't make any changes just yet. If your i1 device cover is in the wrong position, it shows you how to change that right on the screen. Placing the device on the monitor is critical. Tipping the monitor back helps keep it in position. The weight on the cord is also adjustable. Just squeeze the weight and slide it on the cord. The device must lay perfectly flat on the screen. The weight on the cord helps keep it balanced. Once everything is in the correct position, click Next. The measurements begin. The first time it stops, it gives me a brightness reading. Now my target is 120, but the monitor is well over 400. The instructions say adjust your monitor brightness down. Now, because my brightness controls on my iMac are on my keyboard, I'm going to leave it on full, and then I'll let the profile control the brightness, bringing it down to the correct level. This way, I know the correct position for working. That'll be set all the way at full or on high. If your monitor is external, meaning one that is not built right into your computer, you have controls that you can adjust. Make those changes here to hit the target point. Now for these manual adjustments, never go below the target brightness. If you have a choice of going above or below, keep it just a little bit brighter. Click Next. It's now taking all of its color readings. In this case, it's measuring over 100 color patches. Just wait, this will take a few minutes. Don't worry, I won't make you sit through it all. Okay, the measurement is complete. You can now remove your device and click Next. Now, back on the main screen, click Next again. A profile is created and a name is already in place based on the monitor or computer and the date of the profile. After the date, I'm going to add an underscore and I'm going to type in 120 for the brightness level I used when I created this profile. Now I include this in the name in case I need to create future additional profiles for print matching. Sometimes those levels need to be in the 100 to 110 candelas per square meter range. Click Save Profile. Because I had a profile reminder set, I get a notification that the i1 Studio tray needs to run in the background. Just click OK. That'll give me a reminder to run this again in about a month. At the top here, you'll see 3 adjoining icons. The first shows your color model, but most importantly, it shows your target and achieved results. For my white point, my target was D65, which is a Kelvin temperature of 6,504 degrees. You can see the setting achieved is slightly below that. In this case, I'm just a few degrees off. There is nothing I can adjust on my iMac monitor, so it is what it is. If your monitor will not calibrate close to your target, your monitor may be ready for replacement if manual adjustments cannot fine-tune it to where it needs to be. What I achieved here is just fine. I'm within just a few degrees. If you're 50 or 100 degrees off, that's probably not within an acceptable range within my opinion. Now luminance was targeted at 120 and mine actually achieved a setting of 119. Good. Many profiling softwares do not show the results of this profile. This is critical to know where you stand. Some monitors are just garbage and you don't know how bad they are unless you actually see the end result. You can profile a monitor and the software can say it's profiled, but it may not be right. We need to live by the numbers. That's why we need to look at the targets and the results achieved. Clicking the person icon shows example images with different situations and color patches. This gives you the ability to visually evaluate the profile that was created. Clicking it before, you'll see what the monitor looked like prior to the calibration. Now, if you've never calibrated a monitor before, you'll be blown away by the difference. You'll probably hate it. But trust the numbers. You'll get used to the decreased brightness. Now, you can review the profile with other images from the drop-down list. Once you're done reviewing, click Home and then go ahead and just quit the software. Now that your monitor is profiled, it's time to work on an image. If you use a Pro Color Lab, make sure your file has an embedded sRGB profile. This is the standard sRGB profile that's right in Photoshop, not your monitor profile. Some labs will tell you that they'll accept files with Adobe 98, but if you're printing on traditional photographic paper, they just convert them to sRGB because that's the only color range that that type of paper can reproduce. Just use that right from the start. In Photoshop, adjust the color and density to what you want for your final result. You may want to work on a couple different images from different lighting and color situations. Now go ahead and save the files. Send these off to your favorite color lab for test prints. Make sure the lab does not make any color adjustments. This is critically important. When you get the prints back, you need to evaluate these against your monitor. Now this is really hard unless you have a viewing booth. Light levels vary and color temperatures change in every environment. They will even change in your customers' homes depending on where the images are actually displayed. When I evaluate prints, I will do it under a light source that uses a high CRI bulb. That's color rendering index. You want a bulb rated in the high 90s or at least 95 with a Kelvin temperature of 6,500. These bulbs are full spectrum so you don't get color crossover. Now, if you don't have any high CRI lamps, review the images in a mixed light source situation. This is likely what your customers will see. If you look at the print in daylight, it'll look one way. Under indoor lighting, it'll look a little different. That's just the nature of light. Viewing outdoor midday is the closest to your D65. My point is here, you want a print that creates the desired result. If you're making prints for photographic competition, you should evaluate those prints under the lighting conditions specified in the rules for the competition. You need to look at your monitor, adjust an image, then send it off to a color lab for printing. Again, I never want the lab adjusting my files. Once they do, we have no standard and we've introduced a variable. Now I can safely say that I can send my files off to any pro lab and I can get a good result. They should all look really, really close to the same. assuming the lab is not making color and density changes and the paper type is the same. Once you're calibrated, your color should be dead on or at least really close. Again, remember, viewing conditions and color temperatures can affect how the color is shown. The biggest variable you may see between your prints and monitor is on the brightness or density of the image. If your print is too dark, make another profile setting your target luminance 100 candelas per square meter. Repeat the calibration process and review the prints. Now, do they match the monitor? If the print brightness and the monitor now match at 100, you're golden. But if the print is still too dark in comparison to the monitor, create another monitor profile at 90 candelas per square meter. After you've landed on what you think is a match, edit some files again and order new test prints. Once you know the correct luminance level for your prints, use that profile for your print preparation. If you're going to make competition images for digital submission, those that are judged on a monitor, simply change the profile to the one you created for a luminance level of 120. Remember, we added that setting identifier right into the profile name for easy and quick identification. You would then work on your images with that setting. If you want to go back to full brightness for some reason on your monitor, all you need to do is change back to your default profile. You can easily switch profiles depending on the job you're working on. Now, to change your monitor profiles on your Mac, you're going to go to your System Preferences, go to Displays, and then click on the Color tab. On a PC, click Start and just type in Color Management. In any case, don't manually adjust your monitor outside of the calibration process. Leave all that right up to the software. Keep in mind that printed results will change depending on the type of paper you are using. A rag watercolor paper will be different than standard prints, and that's different when you print on canvas. I suggest making your test prints on standard photographic paper, as that has white and black points that are easily mapped against the settings we used in this process. When you are printing to other substrates, you would then use a soft proofing printer profile for the specific medium. These are applied in Photoshop or Lightroom to review the image files prior to sending them to the lab. Now that becomes a whole separate game, and that's really out of the scope of this video. Color management can become extremely complex, but if you do nothing other than calibrate your monitor these settings, you'll be way ahead of where you started. The key is eliminating variables and establishing standards in your workflow. Once you know where you're at, you'll then have a point from which to move forward. I hope you enjoyed this video despite all the technical jargon. Most importantly, I hope you learned a lot. I'm Ron Nichols.